Okay, so problems 30 through, I guess, 34, I'm going to do together in one. Yeah, 30 through 34. Each of these problems can be done using a formula on this formula sheet that you'll have during the exam. In chapter 4 is all about probabilities, so you'll find these formulas all in the chapter 4 section. So we'll start with the first one. If the probability of A is 0.22, probability of B is 0.55, and A and B are mutually exclusive, find the probability of A or B. Now, what the first formula is for mutually exclusive events. It reads the probability of A or B equals the probability of A plus the probability of B. This is if these events are mutually exclusive, which means they don't share any intersection. Those two events cannot occur at the same time if they're mutually exclusive. So the probability of A or B, I just add the individual probabilities. 22 hundredths plus 55 hundredths. So the probability of A or B is going to be 77 hundredths. And that's our answer for number 30. Just using the formula, right? 31, they give us the probability of A, B, and the probability of A and B, and they want us to find the probability of A or B. Now, this is also on your list. This is the addition rule 2, also sometimes called the inclusion-exclusion principle. This is for events that are not mutually exclusive. They do intersect. The intersection is not 0. There's an actual non-zero value there. So this formula reads the probability of A or B is the probability of A plus the probability of B minus the intersection, minus the probability of A and B. Simple arithmetic to substitute these values in. A is 0.28, B is 0.34, and A and B I'm subtracting 0.18. So A or B equals, this is what, 0.62, 0.62 minus 0.18, 0.44, 44 hundredths is the probability of A or B. Moving on yet again, number 32, and we've got some more coming there. So 32, let A and B be events with probability of A, probability of B. Assume that A and B are independent. Find the probability of A and B. The third formula there is the multiplication rule 1 for independent events. The events are independent. The probability of A and B is the probability of A times the probability of B. Just multiply them. Probability of A is 0.5. Probability of B is 0.8. So the probability of A and B is 0.4. 0.40 you can say, but still 0.4. Okay, next 33. Also independent events. So we're using the same kind of formula. The probability of A and B and C. Multiply them. Probability of A times the probability of B times the probability of C. So the probability of A and B and C, I don't want to write that again. 0.4 times 0.8 times 0.6. 0.4 times 0.8 is 0.32 times 0.6, that's 0.192. There it is. I definitely wasn't writing that again. Okay, last one, 34. Let A and B be events with probability of A, probability of B, and the probability of B given A. Probability that B occurs given that A has already occurred is 0.3. Find the probability of A and B. These are non-independent events. That's the next formula, multiplication rule number 2. Probability of A and B is the probability of A times the probability of B given A. So the probability of A and B is the probability of A, that's 2/10, times the probability of B given A, that's 3/10. So this probability is 0.066 hundredths. And that's those.